Hello, I welcome you all. The problem reads cars A and B are traveling around the circular racetrack. At the instant shown, A has a speed of 90 feet per second and is increasing in speed at a rate of 15 feet per second squared, whereas B has a speed of 105 feet per second and is decreasing in speed at 25 feet per second squared. Determine the relative velocity and relative acceleration of car A with respect to car B. Right, this problem is coming from the Engineering Mechanics and Dynamics, 14th edition by RC Hibbeler. Right, so let's add some details to this quickly. So we have a car A, which is increasing, it's increasing its speed at this rate, which is given 15. Let's call this AA. And of course, this also experience some normal or centripetal acceleration that we're going to call A. We'll call A and B. Okay, I mean A and A. Sorry, this is A. All right. So this particular axis here, we'll call it. I'm going to call it T, and then this one we're going to call it. This one we'll call it N. This one is N. This one is T. Right. So these are the ones for A. Let's go to B. B is speed is decreasing at this rate given, so we'll have negative, or acceleration will be in the opposite direction of velocity, like so, and it will also have some centripetal acceleration, like so. Right, so let's give these values some names. These are, so this one is AB, and then this one is A N B. Okay, so this, we have this and also this, these axes, right? So this is T, tangential, and then this is N. Okay, this is N. Right, so for acceleration and for components of B, they are going to have components because they are at an angle. We are using this particular reference, this, like so. This is our reference we are using. All right, so this is our X and this is our Y. So we expect to have components here in this direction, like so. Let's write them down. We'll have a component there, right, and another one there, right, and then we'll have another component there for velocity and another one there, right. Okay, and then we'll have another component for acceleration there, and another one there. All right, so what are the angles for this? The angle for this, so we know that, to say if this is 60, then this is 30, then this becomes 60, right? Is it okay? Should be okay. Great, so let me wrap that. Let's write down that. So this one here is 60, therefore this becomes AB cos 60, and this one becomes AB sine 60. Let's go to the other one. So this one here, if we know that drawing this. This one here is 60, then this is going to be 30. Of course, this will be 60 also. Is that fine? Great. So let's rewrite this. So this angle here, this one here is 60 degrees, and therefore this becomes VB sine 60, and then this one uh, this one becomes VB cos 60. And finally, of course, this one is straightforward. This one here is 60. Okay. Therefore, this one is going to be equal to ANB sine 60, and then we have this one okay, this one which is ANB cos 60. Okay, so we have everything now. Let's write down. Let's start the work quickly. So we have B. We are looking for B with respect to B, right? Velocity of A with respect to B, and this is equal to VA minus VB. So our VB is our frame of reference. So what's our VA? So let's bracket this. VA, let's add up all the components. So I'm going to, okay, so VM, we have VA itself, I, okay, we have VAI, which is a negative, okay, so it's minus VAI, all right, that's all, right? That's all. Then minus B. B has components. It has minus this one in blue, minus VB cos 60, okay, plus VB sine 60. Okay, is that all? Yeah, that's all. So we know that our VA is just equal to VA is equal to 90 and VB is equal to 105. Therefore, VA with respect to B is just going to be equal to, so this one it is just so we have minus 19, right? Then we do have components. Sorry, these are components here. These ones, I mean, this one is in the I, this one in the J. Okay, what to indicate that? So we have minus 19 plus VB, which is 105 cos 60. Okay, so this gives us a minus 37.5i. Then the other one just becomes a minus 105 sine 60. So this just becomes a 90.5 93J. Okay, this is feet per second. And then its magnitude, using Pythagoras theorem, its magnitude is just equal to square root of minus 37.5 squared plus minus 90.93 squared. And therefore, our VA with respect to B, the magnitude is just going to be equal to 37.5 squared plus 90.93 squared. Square root of that, we have a 98.36 feet per second. Okay, it's 105 sine 60. Right, so 90.93 squared plus 37.5 squared, square root of that, 98.36. Let's find the angle. Theta is just going to be equal to tan inverse of the y component, which is 90.93 divided by minus 37.5. Theta therefore is just equal to 90.93 divided by 37.5. Tan inverse of that, we get a 67.59 degrees. And if we were to draw this, it just looks like this. It looks like so. So this is negative there, it's negative there, like so. Okay, and then we have the resultant, which is closer to the y-axis, like so. Okay, and then we have the angle there, like so. Okay, this is the x component, this is the y, and this is our BA with respect to B. So you can also show there, if you want to, you can show like so, and show this component like so. That's another way of showing it. Alright, so we are done with this. Let's move on to the second one, acceleration. So acceleration A with respect to B is equal to acceleration A minus B, and this is just going to be equal to, this is going to be equal to, if I move it somewhere here, okay, move it somewhere here, this is going to be equal to, let's write it down, acceleration, what do we have? So we have minus AA I and minus AN J, okay, for this part and this part. All right, so for B, we have this is A, okay, so this is A, we bracket this, and we say minus, let's open for B. B, what do we have? B, we have 2, so we have AB cos 60 I minus AB sine 60 J, and then we have what else do we have? This, we could have used this space as well here. I think it doesn't harm. We could have used this space. This space is fine, right? So I think we can leave this. and then move this just a little bit behind, maybe somewhere there, right? Great. And also this one maybe somewhere there, like so. Great. So this, and then we can say this is one part, then we can say minus a n b sine 60 I, okay, then minus a n b cos 60 j. All right, so we have AA here equal to 15 feet. We have AB equal to 25, right? And then we have ANN equal to VB, VA squared divided by rho A, which is just equal to, our A is 90, so this just becomes 90 squared divided by rho A. Rho A for this one is 300, and this just becomes just 90 squared divided by 300. This just becomes a 27. All right, and then we have ANB is just equal to rho B squared divided by rho B, and this is just equal to 105 squared divided by 250. Okay, and this is just equal to plus 105 squared divided by 250. This becomes a 44.1. Okay, so A with respect to B is therefore just going to be equal to, let's work out now this. All right, let's sum up the I components. So minus AA, which is a 15, then minus AB, which is a 25 cos 60. Okay, and then we have a plus ANB is a 44.1 sine 60. All right, I think this is it, right? So we have a 10.69 I. So this is fine. That's minus 15. Then minus AB, which is 25 cos 60, and plus AB 44.1 sine 60, 10.69. Great. The second one, ANA, okay, it's going down, is 27, that's minus 27. Okay, then plus ANB plus AB, which is 25 sine 60. Okay, and then plus ANB, which is 44.1 cos 60. So this we get a plus 16.70J. All right, let me repeat this once more again. Let me repeat it. I just move it a little bit somewhere there. All right, so we said minus 27 plus 25 sine 60 plus 44.1 cos 60. All right, so this is fine. So let's bracket this in this curved bracket. So this is feet per second squared. Let's find the magnitude. A with respect to B, the magnitude using Pythagoras theorem. There we go. What do we have? We have a 10.69 squared plus a 16.70 squared. Therefore, A with respect to B, okay, will just give us the following. So we have 10.69 squared plus 16.70 squared, okay, square root of that. We have a 19.83 feet per second squared. Let's find the angle. The angle, we have tan inverse, okay, tan inverse of the y component divided by the x component. Okay, then theta is just going to be equal to 16.70 divided by 10.69. Okay, and what we have is a 57.38 degrees. Okay, let me repeat it. 16.7 divided by 10.69. Okay, 57.38. So let's write down what we have. So we have something like so, something like so. Oh, sorry. We have something like so. They are both positive components. Okay, and then we have the resultant to be closer to the bigger vector, which is the y. So we expect it to be somewhere bigger, somewhere there like this, right? So this is our A with respect to B, and then we do have the angle like so. That's the angle. This is the x and this is the y. I guess we are done. Let's outline the solutions. We have the vector expression for velocity, okay, of A with respect to B. We have the magnitude there. There we go. We have the magnitude, and then we have the angle. Okay, we have the angle. There we go. We have the angle, and then for acceleration we have the vector expression there. There we go. Okay, we have the magnitude. There we go. Then we have the angle. Okay, so we can also add the component here like so. We can write this as this, then we say this. If you want to just show to say this angle is in this direction. Okay, so let me write this properly. So we have the horizontal, then we have resultant, then we do this. All right, so this is the angle there. It's like so. Right, I think we are done with everything. And I hope this particular video is helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.